him to do that thing again. I go, my differentiation and integration strategies are pretty good.
Most of the time, you will not be able to evaluate this integral. However, sometimes you can. And you will have some homework to do it exactly sometimes. It involves a lot of algebra. Let's do an example where you have to do it exactly. Here's an example.
Just to make
We want to find the curve, the length of the curve 1, 6x cubed plus 1 over 2x. From x equals 1 to x equals 2. I don't know what this curve looks like. You can find the length of that curve. So we have to take the derivative of this function, square it, add 1, take the square root, and integrate it. The question is, does it turn out to be something that's easy to integrate? Let's see, what is the derivative of this function?
1/2 to the 4 x to the
The derivative of this function is what? 3 over 6x to the power 2, which is 1/2 squared, and this?
1/2. No, wait, I'm sorry, is that at -1?
Yes.
Or, that would be negative 1 over x squared.
1 over 2x squared.
2x. Oh.
I'll take out the 1/2. So now I have to square this. I have to square this, add 1, and then take the square root. And integrate from 1 to 3. So what is the square root of this? What is x squared minus 1 over x squared squared? Huh? I fold it out, huh? Onto x squared times x squared, which would be x over 4, minus 1 over x squared times minus 1 over x squared would be plus 1 over x over 4. X squared times minus 1 over x squared.
That'd be -1.
I have 2 of those.
So minus.
So now I have to add 1 to this, take the square root, and integrate. So we're going to integral from 1 to 3, the square root of 1 plus. This. Question is, does this simplify to something you can integrate? It so happens that it is. Hold on, we get it here. This is the square root of 1 plus 1/4 x to the 4 minus 1/2 plus 1/4 1 over x to the 4. Yes. And then we have the 1 minus 1/2. 1/2. I'll take the 1/4 out as a common factor. One-fourth out. One-fourth times what?
X to the
6 to
four
the 4
plus 2 plus 2
plus 2 plus,
x 1 over x.
and this is a perfect square. This is a perfect square, so I'll be able to take the square root of it. Now I'll take the square root of that. This is a perfect square, what is it?
X squared plus x to the negative
X squared plus 1 over x squared squared. X squared plus 1 over x squared squared. And when I take the square root, then it's something like this. Take 1/2 out. What's the square root of this?
2. That would be x squared plus 1 over x squared.
So is that one of those things that you just know, or like what's the mathematical basis behind that?
So you have to do some algebra. So if you have a homework question, they say find the length of this curve, and they say evaluate it, then you're going to have to do some serious algebra to get something to take the square root of. Okay. Yeah. But most of the time, of course, it will be a highly concocted example. Why would you have something you want to find the length of that curve? Why would you want to find the length of that curve? You usually want to find the length of the curve that's interesting, but then that turns out to be a bad integral. So here you will be tested on your algebra. You will be tested on your algebra. Okay, I'm going to leave the length of a curve alone. The next application, we're going to do some applications in physics. And the first one is work. Anybody know what is the physical definition of work?
Force over distance.
Applied force.
I'm sorry?
Applied force.
Force is a force. What is a force?
Acceleration times mass over,
Anybody know what a force is? Huh? Who's taking physics? What's a force? Huh?
I'm just calling her out.
What's a force? You don't know what a force is, you better ask your physics professor. Because I think they can't do any physics without understanding what a force is.
I mean, this is just change over, like here. It's an exertion to move something, or to stop something, rather.
Huh? Oh, may the force be with you. Who knows what a force is?
It's energy that can be pushed.
Oh, no, energy is work. Who knows what a force is? No good physics professors on campus here.
I mean, it's just it's acceleration on a mass.
No, you guys don't know. Nobody knows what a force is. A force is something that causes a body to accelerate. Professor, tell me that.
I was just about to say that.
Ah, right, Mr. Harris. Force is something that causes something to accelerate. That is, you go out in space and you look at a body, and you put your hand out there, and you stop that body. The body's traveling at a constant, it's moving at a constant velocity. You put your hand there, you cause the velocity to go to zero. In order to do that, you will have to apply a force. So a force is something that causes something to accelerate. That's why they have this nonsense here, force. Force is mass and acceleration. So if I apply the same force on two people, one of them is a sumo wrestler, and the other one is a ninja warrior, and I want to cause them to accelerate, I'll have to apply a bigger force on the sumo warrior, the sumo wrestler. If I want them both to accelerate at 2 meters per second every second. By the way, anybody knows what acceleration is?
Change in velocity.
Right. So in other words, if you're having a body out in space, moving at a constant velocity, it is not accelerating, so there are no forces acting on it. And you can go out in space and you can look at things, it's moving at a constant velocity. If it is accelerating, then you know that there is something acting on it, some force. So when it starts, you'll see a body out in space, moving at a constant velocity. When it gets into the Earth's gravitational field, then it will start to accelerate.